Hello and welcome to this video in this series teaching C#.NET for engineers. In this video we are going to look at some very basic coding concepts, and we are going to start right off at the beginning by talking about the variable. Now the reason I'm starting with this very basic concept is because I can vividly recall my student years back in the 1990s when I was already a third year engineering student and I had to take a programming course at university. And most of the other students in the class were not civil engineers. They were actually electronic and mechanical engineers. And we were only a handful of civil engineers. And I don't know about the other civil engineers that were with me in the class or civil engineering students that were with me in the class. But when I was at high school, I tended to spend my time doing a bit of sports and reading war novels, while most of the students that were studying mechanical engineering and electronic engineering were already playing with circuit boards and writing small little programs on their Commodore computers. And so programming was an entirely new concept to me. And the lecturer that was very obviously very bored teaching this course to engineers from the computer department, he said that actually for engineers it's easier teaching programming because, and I recall he said, you'll all already know what a variable is. And so if I write something like this, you all will understand what I mean. And I was completely dumbstruck because I don't understand what that means. What does x equals x plus 1 means? So I was looking at that as an algebraic equation, and of course as an algebraic equation it does not make sense. And most of the other students in the class understood what this means. So for those few of you out there who are also a bit confused by what that statement actually means, what the lecturer just omitted to say is that when a computer program executes, the code is executed from the top to the bottom and from left to right. So as the program gets to this line, x is a variable that has a certain value in it, and when this line is completed, x is going to have an increase of 1 in its current value. It's as simple as that. So I just want to be sure that all of you going forward in this course are very clear on this concept, because it may seem very, very basic, but it is very fundamental to how a program actually executes. So let's look in more detail at the variable and code execution. First of all, we have the concept that we have to declare the variable. We have to tell the computer that this x is a variable. And so by making that declaration, we tell the computer to create a space, a little box in memory that will hold values assigned to the variable x. And next we assign a value to that variable. This tells the computer that the variable called x now holds a value of 10. So if you imagine that memory space allocated to the variable name x as a little box, inside that box will be a value of 10. And we can go in that box and ask, what's your value? And it will tell us, your value is 10, right? So if we have another statement, remember from top to bottom. So at the top we declared the variable. The next line that executes assigns a value of 10. And the next line that executes assigns a value of 20. So this tells the computer that the variable space called x now holds a value of 20. And the next line perhaps looks like this. And it says x equals x plus 5. Now that's not an algebraic equation, it's a statement in a computer language. So this tells the computer to add 5 to the current value of x. So the current value is x, and when it is executed, x is going to be equal to the current value plus 5 after that line is executed. So since the current value is 20, the value will be 25 after this line of code has actually executed. Okay, so how do we declare variables? If we go back here, we say the very first at the top, we have to declare a variable. If we try to use a variable that's not been declared, C# will not even compile, right? So the program you won't be able to run it because it will tell you the syntax is not correct. So how do we declare a variable? So this is the way that you declare a variable. First off, you put the variable type. So a double precision number is going to be our variable type. and next you put the variable name. X is equal to 10. That is the current value assigned to X. Now you don't have to do this in C#. You can just put your semicolon, which signifies the end of a line of code. That's also quite important. You can just put it behind the X, but typically you would do this to assign a value to the variable, an initial value, when you declare it. Now this syntax is a little bit strange. If you are coming from another computer language, such as when I was starting to learn C#, C# was about my fourth computer language, and all of them were a little bit difficult for me to master. And so when I came to C# from Visual Basic, the way that you declare a variable is by saying dim x as double. That is a little bit more intuitive, because dim is like a syntax statement that declares a variable, and this statement as double is sort of makes it a little bit more intuitive to say I'm declaring a box there, its name is x, and it's going to be a double precision number, and its value is 10, right? But so just remember, in C# you always put the type first, then the name of the variable, and then the value. So let's just look at some of the primitive or basic variable types in C#. So we have the floating point types. So we have a single precision number that takes up a memory allocation of 4 bytes, and a double precision takes 8 bytes. So in C# you can declare a variable with a type float, or you can call it single for single precision. Any of those two names will work. If you type the name wrong, for example, if you make a spelling mistake, the Visual Studio compiler will not compile the program, and it will show a little red line there to tell you, I don't know what this type is. Then you have your integer or integral type. So you have a byte. It can take a value from 0 to 255. Of these, the most important probably is the integer. It takes 4 bytes, and you can see it can hold quite a big range of numbers. Of course, these are whole numbers. They can't have decimal points. They are integral types. And of all of these, probably the ones you will use the most is just simply the integer. But if you have for example, a database with trillions of rows in a table, you will want to use the long decimal type, or the long integral type, which is 8 bytes, similar to a double precision number. And this can take much more a higher range of numbers than can the integer. Most of the time you will be working with double and with integer and maybe with long. Also, character variable takes 2 bytes, a single character. And quite important is also the string type. Now the string is not a primitive type like these other types, because a string consists of any number of characters, and we don't know at compile time how many characters there will be held. So unlike the primitive types that have a fixed memory size, the memory usage of a string depends on the number of characters it holds. Okay, so that's basically just the basics that has to be quite well settled in your mind before we're going to go in the next video and start looking at actual code. So let's just go and take a quick hands-on demo of these principles in Visual Studio. All right, so here I have my program file that sits here in my app. So I'm presuming that you followed along in the preceding videos and you've got these two projects in your solution, and I'm in the program.cs class of my application that can run, called my app. And I'm just going to delete here what we did in the previous video, and let's just do a bit of variable declaration and assign some values to the variable, and we'll use the debugger to step through those variables and inspect their values. So let's declare a double x equals 1.0, and then we will write out the value of x to the console. And let's do this. We'll put the value is, and this is the way that you can concatenate a string. At runtime you can just put a plus, So you've got two string values, you can put them together like that. A more elegant way of doing it, and I'll write this just one underneath the other, is to do it with a $sign, and now you can write it like that. So you don't have to use the plus sign. You can put these squiggly brackets, curly braces, and you can put the value of any variable in there, right? Now notice X is currently a double type, and I'm mixing it here with a string type. So the compiler will allow that, but it won't allow that if you have got different numerical types. You have to convert the one type to the other type before you can mix them or assign one value to the other. Okay, so let's just do one more thing. Let's say X is equal to X plus 6.7. Right now, because it's a double type, I can have a decimal point there, and I can actually say 768,934, and it's a double precision. It can easily handle that many decimals. So now if I do, I'm just going to take this line and I'm going to ask that to be written out to the console, and I'm going to now also declare another variable, and I'm going to make this an integer variable, and I'm going to call this counter is equal to 0, right? And then I'm going to say counter is equal to counter plus 1, and then I'm going to write that out as well to the console. If I say equals X like that, you can see there's a little red line there, and the error says you cannot implicitly convert a type double to an integer, because you see counter is an integer and X is a double type, and I'm assigning the value of X, which is a double type, to the value of counter. So the way to take care of this in C# is to convert X explicitly to an integer, and the way to do that is to use convert to integer, right? And we just use a 32 integer there, and you do it like that. Now you'll see this will work, right? And so counter is going to convert, and that will probably be a rounding exercise, the current value of X, which we last assigned here, and it's going to convert that to counter, and we can now write the value again of counter to the console. Let's do one with a string. Name is equal to John, and then we can write the value of name, and then we can say and we can make another variable, or let's say, yeah, let's make another variable, and we call this full name. Notice I'm using camel case, and I'm going to say John plus Doe, but instead of doing that, I'm going to say it is name. Let's call this first name. So I'm going to click on that, and I press F2 in Visual Studio to rename, and then I call this first name, camel case, and you can see because I renamed, Visual Studio renamed the instance of that name everywhere in the code. So I'm going to say full name. Let's do this like this: string last name equals Doe, and I'm going to say full name equals first name plus last name. Notice I put an empty space in between to just leave a space between the two, and I'm going to write that out to the console again. Now again, notice you'll see with my Visual Studio, because I've got GitHub Copilot, it's costing me $10 a month. I recommend that you try to go without it for a while, and then you can consider getting it. It's very important to type out and get that muscle memory and memory of the naming conventions and the syntax going before you actually start accepting the help of the artificial intelligence tools. Okay, so let's write this out to the console. I'm going to write the value of full name is full name. So if we run this, it's going to go in one run. I'll just put here console read line at the top, so the application stops and doesn't just run through and closes down immediately. So if I run this, it's going to do, let's just see what it will say the value of x is, and then it will see this second line here is just a variation of the first one, where we put the dollar in front, and that allows us to use to explicitly include variables using these curly braces. So this is a little bit neater way, a formatted string, than this way, and I'll just use this. So I'm going to delete that. And then now if I run this, it's going to write all of these one after another. Of course, this is not output to the console. These other lines, they are just code instructions. We're only going to see in the console what was written in here. So let's run that. And there you can see the value of x is 1, and then the next one, the value of x, we've now added 6.7, so it's 7.76 and so forth. And then I've got counter, value is 1. So I assigned initially a 0, and then I added plus 1. Right, so we can see that's what we got there. Then the value was 1, and then we converted the current value of x, which is 7.7. I converted that to an integer, and it rounded it to 8, so the value of the counter was then 8, and the value of name was John, and the value of full name is John Doe. Okay, so that's how that works. Now let's just use the debugger in Visual Studio to look at these variables explicitly as we step through the program. Now don't worry, I'm going to now introduce the debugger and show some details of it. It may be a little bit overwhelming. We'll have a separate video dealing specifically with debugging in Visual Studio. So for now, just assume that the debugging is something that you can use in Visual Studio that allows you to stop the program as it is running and look at the current value of certain variables inside the actual code. So it's a very useful tool to find problems and also to understand how your code is actually working. So the way to do to use the debugger is to go, and in the sideline, you can see there in the side, if I hover my mouse over this little gray bar, it brings up a little circle there. Now if I click there, it is going to do that. You see it's highlighted it, and there's a point sitting there. That means that is a breakpoint. So the code is going to run up to that point, and it will stop there. Now notice this only happens in the Visual Studio environment. If you compile your code and you still have breakpoints in the code, the compiler, when it creates the .exe file, it's going to discard those breakpoints. So if you give this to a colleague, even though you've got some breakpoints in the file, the code will run without stopping at the breakpoints. But in the Visual Studio environment, it will stop at the breakpoints. So now let's run this, and we run it by clicking on the green button over there, and you can see that here's my console, but you can see in the background the code has stopped there. Now if I hover my mouse over X, can you see that Visual Studio tells me the current value of that? I can also right click on X and go down here and say add watch, and if I do that, I will see in the watch window down here, I will see the current value of X, and I can monitor that as I step through. So let's see how we step through. These little buttons up here allow me now to step forward. If I press the green button, it's going to go on to the next breakpoint, or if there's no breakpoint, it will run right through the program. But what I'm going to do is to use this button here to step over to the next line. So let's do that. You can see I clicked only once on it, and I'm here now, and the value of X, if I'm at the start of this line, is still 1 because this line has not yet executed. If I step once more, the value now becomes 7.76, and we write that to the console, and you can see the console now has 2 lines. It says the value of X is 7.76, and now we can go on to counter. If I hover over it, counter has a value of 0. I can right click and go to add watch, and I can see what the current value is, and I can step forward, and counter now has a value of 1 because it was initially 0, and then I added a value of 1, and I write that to the console, and now I'm going to convert counter to X, right? So counter is still 1, but if I execute this line, you can see counter now has a value of 8. I can write that to the console. See how the console is slowly adding these statements. And then I assign a variable. First name is John, right? Notice if I hover here over last name, it says null because there's nothing assigned yet to last name. But the code is still before that variable is being assigned, right? So if I right click here and I say add watch, now I can see what is the value of first name. I step forward, I have last name, I have full name, and I write that out, and here I have now everything written in my console, and now I've basically run through the program, and I can press enter to close down the program. Now in this code I have distributed my variable declarations throughout the code. Normally, if you are inside a function, or as we will call it, a method in C#, it's good practice to actually put your variables at the top. At least that's the way I prefer to do it. So I would not do something like put here double x equals 1 and then lower down integer counter equals 0. I will rather structure my code so that my variables are sitting at the top. Now notice if I take this, if I cut that, you can see I have a red here because now I've taken out that variable declaration. So I'm just going to paste that again at the top, and I'm going to do the same with last name, and that is all I basically need to do. So there's all my variable declarations. Notice it's the declarations, not the modifications of the variables, that sits at the top. And if I run this, I'll get exactly the same result as before, right? So this is it's better practice to put your variable declarations at the top. Okay, so that's it for the quick hands-on demo. So as we said in the previous video, the next video will be the one where we are going to look at the very important concept of a C# class. We'll look at the structure of a class, taking a very detailed look, and then we'll also look at variable scope. So remember, in this video, we spoke about variables. In the next video, we'll talk about variable scope, and I'll explain that concept for you in the next video. So that's it for this video. Thanks for watching.